In this tutorial, we're going to learn how to solve quadratic equations by factoring and then applying something known as the zero product property. So let's quickly remind you of our previous method. So far we have a square root method, which works when we have no linear term. So in this problem, I would add 35 to both sides and I would get x squared equals 36. How do I solve it? I take the square root of both sides, and the moment I do, I need to remember that there are two solutions, plus or minus 6. Remember that this would be the x-intercepts of the corresponding function. So what would we do in the next scenario? Notice that this time we have a linear term. So if we tried our previous method of adding 35 to both sides and we get 36, where do we go from here? We couldn't square root both sides because we have a linear term and a quadratic term. We hit a dead end with our current method. So this is why we need another method. So to figure out how to solve this, consider the following statement. If 4 times a equals 0, what do you know? Well, hopefully you recognize a would have to be 0. Well, what if we had ab equals 0? What do we know? Well, a could be 0, and like b could be 9, because 0 times 9 is 0. Or maybe b is 0, and a is 17. So we could conclude that a or b is 0. This leads us to a very important property known as the zero product property, which inherently you understand if you understand the logic in the previous two statements. It states for all real numbers a and b, a times b equals 0 if and only if either a is 0 or b is 0. How does that help us? Well, consider the following quadratic equation. It's quadratic, but it's in factored form. Factors are things multiplied together. So you could think of this as my a term and my b term. Applying the zero product property, since it's equal to 0, says that either x minus 3 has to equal 0 or x plus 4 has to equal 0. And we can solve both of these statements. I add 3 to both sides and I get x equals 3. Or, in the second statement, linear equation, subtract 4 from each side and I get x equals negative 4. So here are my two solutions. If I were graphing the corresponding function, my x-intercepts would be 3 and negative 4, looking something like this. In number 2, I have 3 factors that include a variable. So this time, this actually wouldn't be quadratic, it would actually be what we call cubic. I'm going to take all 3 statements and say all 3 of them could be 0. I'm just going to move this over, give me more space. So I'm going to get 3 answers here. If I divide by 6, I get b equals 0. Or, subtract 5, I get b equals negative 5. Or, subtract 2, and I get b equals negative 2. So 3 possible solutions in this equation. Now, most times your problem will not be given already factored. So here's a quadratic equation, 5z squared equals 80. I would tell you that we could do this one by our previous method, the square root method, but let me show you how it can be done by a new method. We want to begin by always placing our equations in standard form, okay? So if it's quadratic, x squared plus bx plus c equals 0, we know that. If it's cubic, it just goes in descending. Put your cubic first, your quadratic, your linear, your constant equal to 0. So I need to get this equal to 0 so that I can apply the zero product property. So in standard form, it would be 5z squared minus 80 equals 0. Next, I'm going to factor the polynomial. All right, so hopefully you are really good at your factoring methods. I'm going to start by factoring out the GCF. That's always my first factoring method. Gives me z squared minus 16 equals 0. I have a binomial. I recognize this inner part here as my favorite factoring pattern, the dots pattern. This factors into the difference of two squares. Take the square root of z squared, the square root of 16 is 4, and the pattern is 1 is a plus and 1 is a minus, equal to 0. All right. Now I apply the zero product property, which says anywhere that I have a factor, I'm going to set it equal to 0. Well, this first one, because it doesn't have a variable, doesn't make sense to say 5 equals 0. That doesn't give me a solution. If I go to z plus 4, set that equal to 0, or z minus 4 equals 0. These two will give me two solutions. The first one gives me z equals negative 4, or z equals positive 4. So the two factors with the z give me two possible solutions. Okay, let's do some practice problems. So in 3, it's definitely not in standard form, so I'm going to move everything to the left by adding 4x to both sides, and then I will also add 7 to both sides, and add 7 over here. All right, so my 7's and my 4x's cancel to give me 0 on the right. On the left, I'm going to put things in standard form in descending order of the degree, so I've got x squared plus 8x plus 7. All right, so standard form. Second, I'm going to factor. It's a trinomial. There is no GCF. So you can do tic tac toe or whatever factoring method you want off on the side. That gives me x plus 7 and x plus 1. Now I apply the zero product property, which says x plus 7 equals 0, or x plus 1 equals 0, and I will apply or solve each of these. That gives me x equals negative 7 when I subtract 7 from both sides, subtract 1 from each side, and I get x equals negative 1. So here are my two solutions. Again, these would be the x-intercepts or the zeros of the function. All right, number 4, I would like you to try on your own. Press play when you're ready to check your answer. Hopefully you started by placing this in standard form, which produces v squared minus 9v plus 20 equals 0. Next, we're going to factor a trinomial. There is no GCF. So my factors of positive 20 that add to negative 9 would be negative 4 times negative 5, and that does add to negative 9. So there are my two factors. Up on the side, I'll just remind you of the Tic Tac Toe Method that you can do. You list your factors of v squared, your factors of 20, positive 20, so that they add to a negative means the signs are the same. They're both negative. My factors of 20 are 20 and 1, 4 and 5, 10 and 2. I always start with the two closest together. So I'm doing 4 and 5. I multiply straight across, gives me negative 4v. Negative 5v does add to negative 9v. So yep, on the diagonal, I am correct. If you struggle with factoring, please go back to your factoring folder in Schoology for assistance. So I have v minus 4 equals 0 once I apply the zero product property, or v minus 5 equals 0. Solve each of these linear equations now by getting variable alone. So v equals 4 or v equals positive 5. Number 5 looks simple, but notice that it's not equal to 0. What I sometimes have kids do is they say x plus 3 equals 9 or x minus 5 equals 9, but if I had a times b equals 9, we could not say that it's true that a is 9 or b is 9. Maybe they're both 3. Maybe one of them's 4.5 and the other's 2. So there's no such thing as a 9 product property. So what you have to do is still put this in standard form. So how do we do that? We're going to distribute. We get x squared minus 5x. Distribute the 3, gives me plus 3x minus 15. And I'm going to go ahead and subtract this 9 right away. Minus 9, so it'll equal 0. Combine all my like terms, gives me x squared minus 2x minus 24 equals 0. We're going to factor. Do I have a GCF? Nope. So you can do tic tac toe off on the side or whatever factoring method you prefer. Pause when you have it factored, come back. Gives me negative 6 and positive 4 is what works for me. It's the only thing that works. Now we apply the zero product property, which says take each factor and The first or the second could be 0. So there will be two solutions. The first will be x equals positive 6 or x equals negative 4. Again, those would be your corresponding x-intercepts, zeros, solutions, whatever you want to call them. All right, number 6, last one I'm going to do in this video. Place it in standard form by subtracting 10w squared from each side. Produces w cubed minus 10w squared plus 21w. So hopefully you notice this is more than quadratic. This is what we call cubic because the highest degree is 3, but we can still solve this using the same method we've been doing. We start by factoring. I see a w in all 3 places, so I'm going to factor out the GCF, which now drops the inner part to a quadratic. For the remaining trinomial inside, I'm going to factor that, do tic tac toe or your preferred factoring method off on the side. Don't forget to bring down your w. Come back when you have it factored and fill in your 2 factors. I get w minus 3 and w minus 7. Now I'm going to apply the zero product property since it's factored, and I get w equals 0, or w minus 3 equals 0, or w minus 7 equals 0. So my 3 solutions would be w equals 0, w equals negative or positive 3. If I add 3 to both sides, add 7 to both sides, and I get w equals positive 7. So here are my 3 possible solutions. Interestingly, well, what would this graph look like? Well, we haven't looked at cubic stuff, but it's kind of interesting to see. Crosses at 0, 3, and 7. So it could potentially look like this.